Hello world, welcome back to this tutorial on building a Linux from scratch system. Now the last time we've managed to enter the change root environment, and this is where we will continue. We are in chapter 7 now, and pretty much the first thing we will do inside the change root environment is we will create a lot of directories. So I think this is a good time to start talking about the directories in Linux systems, or Unix systems in general. So just let's look at the ones that we already have. So we have a boot directory. This is where you would find the bootloader and the configuration of the bootloader, and also the kernel, possibly initial RAM drive, so initial init-rd stuff. That would be in boot. Then we have etc. Well, this is where you will find a lot of configuration files for the whole system. So configuration files that would be system-wide. So not your personal configuration for your user, but system-wide stuff like hardware configuration. And I really don't know why it's called etc. I've read there was a discussion on Slashdot once where they debated what etc stands for, and I think the best answer I've seen there was extended text configuration or so, but I don't know, it really looks like etc, and like they just couldn't decide a name for that directory, or maybe they decided to put the configurations there after creating the directory for any miscellaneous stuff, you know. So they could have named it CFG if you ask me, but okay, that's the way it is. So that's where you find your configurations. So we don't have a home directory yet. We will create one today, I think. Yeah. The home directory, so maybe I will show you this here in a new tab. So this is a root directory of my system A, so to speak. So the whole machine, my whole computer here. And here we have a home directory, and in there you find the directories for the different users. So there would be the configuration file for the different users, like for example, the different logins, the different cookies for websites that you've used, or your most recently used lists for your Office applications or whatever. So also your desktop, the stuff that's on your desktop, your downloads would be in there. Then there is the bin directory. This is where you put binaries. So that's why they are called bin. Binaries are the Unix or Linux equivalent of .exe files on Windows. So these are really programs. On Windows you would normally put programs together with their libraries into one directory under C program files. On Unix systems you separate them. So you have the binaries, which are the programs that you can start, and then the libraries are in lib. And also lib64 for 64-bit libraries. The reason for that is because on Unix-like systems, you are trying to get to use the same libraries more. You know, on Windows, each program has their own libraries. Here we are trying to have the programs, or have all the programs use the same libraries for consistency or to save space, probably. Okay, then we have sbin. Sbin is for system programs, so also binaries, but so bin would contain something like maybe a web browser or an Office solution. And sbin would contain stuff like fdisk or mkfs, you know, these programs to manage the hardware. So bin is more the stuff for users, and sbin is for system management. And I don't think normal users even get access to sbin. Let me see. Yeah, as you can see here, I don't have access to sbin. I only have access to user local sbin. Yeah, because that's stuff for system management, and as a normal user, I'm not allowed to do any system management, so I don't need access to these files anyways. So administrators, the root user, would have sbin in their path variable. Then we have a very important directory called user, or USR. Which contains a lot of interesting things. So in user you have another bin directory, another etc directory, a lib directory, and also a local directory in there that has another bin directory, etc, lib, sbin. So the reason for that is so the user directory is stuff that is more for the regular usage. So the user directory is for stuff that is for the user. I mean, bin is already also stuff that's for the user, but I think the difference between bin and user bin is, for example, is that bin would be stuff that's more necessary. So stuff that you need to boot your machine, because the directory bin is required to be on the same partition as is required to be on your root partition, and user bin is not required to be there. So the idea is that when you are booting, you might need stuff from bin, but once you have booted, part of your boot process might be to mount another hard drive or maybe some network location and mount that to USR, and then you have these additional programs that don't need to be installed on your hard drive. So like if you run a big company, maybe everybody mounts the user directory from a common network source, and then you only need to manage that network source. So you only need to install stuff there, and then everybody in the company has it. So you don't have to go to each machine and install it everywhere. Yeah, and the same reasoning is behind the fact that the root directory is here. Root is the home directory of the root user. So administrator user. So, well, home directories are normally under home. Why is this one not under home? Yeah, for the same reason. Because the home directory might be loaded from some other network resource or some other hard drive, and maybe if that drive is broken or the network is down or something, then you might not be able to log in as root if the root directory was in here, but that's why the root directory is again required to be on the same partition as on the root partition. Okay. One thing I forgot to mention is in user share. There's a lot of stuff that would be like image resources, like the icons here for your file manager would be in there, or your desktop background images will be in there. Probably you see there's some icons, they are a bit distributed. There's also the include directory here, which contains the header files for C and C++ are in there. Again, user is at least shared between the different users on the same machine. So why would you have the same library twice? It doesn't make sense. So you would put that under user. Actually, I think include should be under user share, but whatever. So these are things that every user might need for some reason, and it doesn't make sense to limit that, because why would you limit one desktop background image to one user alone? I mean, if you put it here, everybody can take these background images as they want. You know, there's these background images, and it's accessible to all, so everyone can select any one of these. So the man pages are also in here somewhere. Here, there's the man pages, the documentation of the different programs. Okay, these might be the most important directories, at least the most important real directories. There's also dev. We've seen dev before. Dev is not an actual directory on the hard drive. Dev is a so-called virtual directory that is created by the kernel at runtime. So this is where you would find stuff like here are, for example, the files that represent my hard drives, right? SDA and SDB are the hard drives. SDB is the USB key, and then you have these other files here that represent the different partitions on the hard drive. So if you want to access the hard drive, you would at some point talk to one of these files. You know, like here, where is it? Yeah, here, this is how I mounted the USB key, right? I said take this device file and mount it under mnt-lfs. And mnt-lfs is another directory, or mnt itself is another directory. This is where you would mount whatever. You can mount network locations, hard drives. You can mount them there. It's not really common to do that anymore. Because yeah, I think with the USB hard drives, external hard drives, this became a bit this became too inflexible. So when you attach a hard drive just while the machine is running, the system must do something with it, and if you're logged in as a normal user, you cannot just mount it to the system location. So instead, nowadays, it would be mounted probably to media or something. Yeah, today this might be mounted on /media or something. Whatever. Then there's more. Then there are a few more virtual directories. We've already seen dev. Then there's also proc, which contains entries for all the running processes. So these should be the process IDs, and then you have all sorts of things to interact with the running processes. I think if you run something like PS, which lists all your running processes, that's probably reading proc, or also top. It's probably reading this directory. Okay, then we also have run. I think that's for system services, for daemons. You know, I have Samba here, which is a Windows network sharing protocol. OpenVPN. Why do I have an OpenVPN on this? MySQL server. What else do we have here? CUPS, the printing system. DHCP, which configures your network automatically. Docker for for something like cloud computing. Yeah, good stuff. Systemd. And then we also have this, which contains all kinds of stuff to communicate with the kernel. So, for example, I think devices. I think these are the running kernel modules, like for like the different drivers. Here FS is, has probably something to do with, these are different file systems. ext4 and fuse are file systems. Modules is probably something to do with kernel modules. I guess if you mod probe something, so you load some kernel module, then it might talk directly through this directory here. I'm not sure about that, but might be done through some system calls, but yeah, buses, your ACPI AC97 is, I think, for audio, your CPU, NVMe sounds like it has something to do with my graphics card, NVIDIA, your PCI bus. Yeah, so that's what this is for. Oh, Xen is also in here. Okay, so that much about this. There's also temp. Well, you need some place to put some temporary files sometimes. Yeah, that's temp. Then there's opt. That's a bit. We are at this point. We are somewhere where it's a bit debatable. You know, the distributions don't do these things the same way always. So you might find different things in opt. So here I have EM SDK, which is a programming language or a compiler for LLVM, a Clang-based compiler for LLVM, which produces WebAssembly files from your source codes. Google Chrome is in here, but it doesn't have to be. You know, Google Chrome can also be on bin. I don't see a reason why it should be here. Other distributions also might put their desktop managers in here, like SUSE, I think, at least at some point put KDE or GNOME here. It depends on the distribution what you will find there. Then we have var. I think var stands for various, which is just some stuff that didn't fit under anything else. Like, yeah, what does var mail have to do here? Doesn't make sense to me. Var log files could be on the root directory if you ask me. Log files for mutual exclusion stuff. You have a temp directory here. Yeah, you might put games here, but that's also somewhat dependent on the distribution. I have a spool directory here. Spool is, of course, the printer queue. And then we have SRV, which contains files for different server. If you share something like through FTP or HTTP, okay, these are empty here, but if you installed a web server like Apache or an FTP server like ProFTPD or something, you might put the files that you share through these systems here, but that's also not standardized. I've also seen stuff in var www for Apache. So the stuff in opt, var, and SRV is kind of like dependent on the distribution. Okay, so then let's start creating all these directories. Yeah, these are a lot of directories, so, oops, not in Ocular. Okay, creating directories. So inside the inside root directory. Okay. Okay. Now remember, in the change root, the mount point LFS is now our root, so we can just create stuff under the root directory without the $LFS. Since we are in a subshell now and we haven't passed the variable LFS, you could actually have the LFS variable here and it would work, but whatever. So since these are quite many directories, I will just copy this. So what do we have? We have etc, etc-opt, etc sysconfig, lib, lib firmware, media floppy, media cd-rom, user bin, user include, user lib, user sbin, user src, user local bin, user local include, and so on, user local share color, dict doc info, yeah, stuff, many directories. We've discussed the important ones of these. Then a symlink from run to var run, because some distributions do that, and some programs expect that because of these distributions. Then a symlink from runlog to varlog, same reason. Then we create the root directory with relatively strict access rights. So the root user has read, write, execute, and everyone else only has read and execute. And then temp and var temp, everybody has read, write, execute here. Yeah, whatever. So then symlink for proc self mounts to etc mtab. Now this is again something for compatibility with older systems. So older systems had this directly at etc mtab. So this is a list that tells you which device file is mounted to which mount point, and the options and so on. This is how it was done in previous days, but at some point this was moved to, I think, proc mounts also works, and yeah, proc self mounts also works. So yeah, since proc is a virtual file system, I think proc mounts and proc self mounts are probably handled by the kernel, so we don't have to symlink proc self mounts to proc mounts. But this one for historical reasons. Okay, then the etc hosts file is something like a local cache for DNS entries. So if you say something like ping localhost, then then your network subsystem might look at this file and see, okay, localhost is the IP 127.0.0.1, and then it will ping this IP. Okay, and also yeah, so we basically give the etc host file two entries here, both for 127.0.0.1. One under the name localhost and then the current host name. Like this machine has the name laptop, and so I also put the word laptop in there. This wouldn't make sense if I wasn't going to run the system that I'm building on this machine, because then I might have the same host name twice on the same network. So yeah, I think that only makes sense as long as we are running this on the same machine later that we are building it on. Okay, and now we create the different users and the user groups. Now this is again a lot of typing, and I just want to save that. So I'll just copy and paste again from the LFS system. So we have a user named root. This is the random number generator sort, I think, user ID, group ID. That's just some string to describe the user, his home directory, and the program that is run when you log in as that user. So if you log in as root, you get a bash, at least as long as you log in on text mode. Then we have bin and daemon, message bus and nobody. Something that they do sometimes is so that they set def null as the home directory, so something that you cannot really access, and bin false as your program that you run when you log in. That's almost a bit funny if you think about it, because bin false does nothing but terminate immediately with an error condition. So if you log in, this program is run and returns, which means that you've logged out again. So if you log in as bin, it will immediately log out again. Okay, then the different user groups. With a name, possibly again a random number generator sort. Group ID, you know, here root has the user ID 0, and the group ID 0 means he is in the group root. Okay. Okay. Now, in the LFS book, what they do next is they install another user. This is a bit complicated. I will copy this again over here, because I don't want to type it. So what they do is they append another entry to the password file. Okay? And every line in the password file corresponds to a user, right? And this is the username here. So we are creating a user named tester. And well, he gets his own tester group with ID 101, and he's in that group then. And home tester is his home directory. We create that home directory here, and he will use bin bash. Now what is up with this thing here? What does that do? And I mean, why don't we just put this user in here directly? So the thing about this code here is, maybe we will just try out what these different parts do. So lsn tty gives us a lot of information about the tty location, which is the file of the pseudo terminal that we are currently running on. Okay, so this is the current pseudo terminal of this terminal session here, and lsn gives us all these informations about that file. Good. In particular, it gives us this number 1001. And I'm pointing that out because in the next step, oops, what have I done? Apparently I haven't copied this. Yes. Okay, so in the next step, this cut extracts that number 1001. Well, 1001, in my case, on this machine with this user, this is my user ID. So if I echo $UID, this is my user ID. I could also get it like this. So why does that code do that? So the reasoning here is sometimes I think some tests need to be run with limited user rights. So this whole stuff here is run as root, right? Because we are in a change root here. And some stuff is not supposed to run as root. And that's why we've created this additional user. And we will run stuff as this user. Now the thing about that is, remember that we are still running our system B on top of our system A, right? So we are still using the kernel of system A, and we cannot just create a user on system B and expect this to work, because if we created a user just with any random number as user ID, and then we told the kernel from the underlying system, hey, run something as this user, the kernel would possibly not know what to do, because that might not be a user ID that the underlying system knows. So that's why we need an actual user ID from a user, from a normal user of the underlying system. So yeah, that's why we are doing this. When I tested this, this did not work out well. because the thing is, yeah, I'm writing this as a script, and the program TTY doesn't work inside a script. So inside a script it will just say, hey, I'm not on a TTY here, or on any tailor type. So if you run TTY from a script, it will just print not a TTY. And well, then LSN will try to read the files not A and TTY, and they are probably not there. Even if they were there, I don't even want to know what would happen then. They would probably belong to the root user, so then you might extract the user ID 0 here, and then you would have multiple users with the same user ID. I think that this would really be a very bad idea. So what I've done instead is, of course, the problem here is that we don't have any user ID. We are inside the change root, and in theory, the outside of the change root doesn't exist. So we cannot just talk to the outside and ask it, hey, give me a user ID of some user. And I think this is more or less a hack here, where it kind of talks to, not to the outside world, but it talks to the shell that it's running in. So yeah, I will just test UID, and then I will just take that from a variable instead, and here I will just pass that variable from the outside system into the change root. Okay. I'm not sure if this $UID is required to exist on every Unix system. If that doesn't work, you might try ID-U or ID-U$user, something like that. But on my Manjaro system, UID works, so I'm just gonna do that. Okay, so I think that is enough for this video. Yeah, what will we do next time? Yeah, next time we will continue compiling stuff, and yeah, we will probably reach, wait, I haven't even run this yet, so that would be not very satisfying for you. So let's have a look over the code again. Yeah, looking good. Okay, let's try. Okay, setting up the change root environment. Yeah, that looks all very good. It creates all the directories, some symlinks. Yeah, this looks really good. So this looks a lot more like this now. Okay, so we now have a pretty full directory structure. We've talked about what this directory structure does, why it's there, why it's the way it is. So again, next time we will continue compiling stuff, and I think we will even start compiling the final system next time. So don't miss that. Tune in next time. If you liked this video, like it, share it, subscribe. And I've told you often enough to turn your ad blocker off, so I want to be annoying, so I'm not telling you that anymore from this point on. So see you next time. Bye.